Okay, so with the final exam review, again, it's basically the same amount of questions. I think there's 30 questions or 33 questions on the final exam, pretty much the same thing here. And this is just a little bit of everything that we've done so far along the way. So we'll just kind of go back and look at everything that's here and see what's, see what's going on with it. All right, very first question. It says to find the excluded values. So it's x squared plus 7x plus 6 divided by x squared minus 11x plus 28. Okay, and when it says find excluded values, that basically means you take your denominator and you set it equal to 0. And when you do that, that's going to, and solve it, that's going to give you all the numbers that would be your excluded values. Okay, and honestly, it's just a factoring, really is what this comes down to. So for a problem like this one, you're going to find the factors of 28, where the sum will equal negative 11. Okay, not 1 and 28. It's not 2 and 14. Only way you can get 11 is with 4 and 7. And again, because the b term is negative, the bigger number is negative. And if you do a positive divided by negative, makes the other number a negative. Okay, so when you factor that one off, it's x minus 4, x minus 7 equal to 0, and then solving each one of those, you get x equals 4, and you get x equals 7. So again, excluded values is just taking your denominator, set it equal to 0, factor it, and then just do a little bit, tiny bit of solving to get the numbers you're looking for there. Okay, number 2, this one just says to multiply. Right, and for a problem like this, even though it says to multiply, you really don't do a whole lot of multiplying. For a problem like this, really what you're going to do is you're going to factor everything as much as possible. And then after you factor, you cancel. And then once you cancel, that's it. That's all you're doing. So even though it says multiply, you really don't multiply. You're going to factor everything as much as possible, and then just go back and cancel everything that you can. Okay, for the top part, 3x plus 3. The only thing you can do with that one is you can factor out a 3. So you get 3 times x plus 1. On the bottom, you've got an x plus 1 here. For that one, there's nothing you can do there, so it just stays x plus 1. And the factoring here for these other two parts left over should be pretty easy. That for this part of it. When you factor x squared plus 2x minus 3, there's only the only factors of 3 are 1 and 3. So from there, it's just a matter of getting the signs correct. Because it is a negative 3, the b term is positive, so the bigger number has to be positive, which means then the other number would have to be negative. Okay, and almost the same thing here with this one. The only factors are 2. Well, it's got to be 1 times 2. And with the sum equal to negative 3, the b term is negative, so that makes the bigger number negative. If you do a positive divided by negative, it makes the other number negative. So in this case, they're both negative. Okay, so factored everything as much as you possibly can. Now you just go back and cross cancel. Take out this x plus 1 with that x plus 1. You've got an x minus 1 here, x minus 1 here, and everything that's left over is what you multiply out. But again, you don't really multiply it, you just put it all together. So you're left with a 3, x minus 2 on the top. On the bottom, you're left with an x plus 3. And that is the final answer that we're looking for. So 2 problems that really it's just factoring. I mean, that's going to be a lot of problems that we go through these. About the only time you're not going to do factoring in the very beginning of it is if you have some addition and subtraction, which is what's coming up on question number 3. So we've got 7 over x minus 5 over x plus 2. Directions on this one said just to subtract. Just as easy could have said add. Okay, and with those problems when you're adding and subtracting, the first thing is if you don't have common denominators, you have to figure out what the common denominator is. You have 2 totally different denominators. So then your LCD is just going to be those 2 different denominators put together. So it should just be x and then x minus 2. Okay, and then just figure out, okay, what do we do different to go from here to here? Well, we changed the denominator from x plus 2 and multiplied it in x, so we'll have to do the same thing here. We're going to have to multiply the top by x. For this problem, we multiplied in an extra x plus 2. Same thing here. Okay, now, with adding and subtracting, here's where you have to fight the temptation to start canceling. That you've got to bring this all together and make it one big fraction, and don't rewrite the denominator, just put LCD, so that you kind of fight that temptation to do that. We're going to bring in the 7 and the x plus 2 minus the 5x, and you've got to work on, and again, once you get the common denominator, the bottom is done. It's all about the top part now. So now you're just going to work on the top. You've got 7 times x, 7 times 2. Okay, and on the top part, you've got 7x minus 5x, which would be 2x, plus 14. And this is one where they may or may not make you go a little bit farther, but if this was me doing this part, I would go ahead, because you can factor the top part just a little bit, to get 2 times x plus 7. All right. Then go ahead and bring back in your least common denominator now that you've got everything done. So that was x and x plus 2. And then if there's anything that cancels, then you can cancel it out at the end. Nothing can cancel because you've got x plus 7, x plus 2. So that would be your final answer. Now, if they counted that wrong on the final exam, let me know, because they may have had you leave this answer as 2x plus 14 where it wasn't in factored form. If that was one of those questions where if they counted this wrong and said the answer was supposed to be like this, it's the exact same answer, just factored a little bit different. So if you get either one of those 2, those answers are good. That's one where you have to, that may be something you may want to let me know once we've taken the exam, that if you go back and review the problems and you're like, hey, that answer was right, but they counted it wrong because I factored and they didn't, and if something like that, let me know, because that's little stuff that shouldn't count against you just because of how they're going to factor that part. All right, question number 4. Ask you to solve compound inequality. We got 3x plus 3 greater than 3, or 3x minus 4 less than negative 16. Okay, so all you're going to do is just solve the two separate parts. For this one, go minus 3. So 3x is greater than or equal to 0. Divide both sides by 3. So it's going to be 0. Okay, then we've got the OR. For 3x minus 4, we're going to add 4 to both sides. So 3x is less than negative 12. Divide both sides by 3. X is less than negative 4. Okay, so your basic solving should be those two parts, and I think it's probably going to be like a two-part answer. They will give you one part where you go back and fill in the inequalities with this part. The second part that they give you below that is they have you do a graph. Okay, and they'll give you all the numbers from negative 11 up to positive 11. You don't need all those, so I'm just going to hit the main numbers that you need here. Basically, you just need these two numbers. You need 0, and you need negative 4. And again, they'll probably have like a negative 11 on here, probably a positive 11, and all the numbers in between, but just to save some time, we're not going to hit all those. Basically, that's what we need. We need the two numbers that we've got from our graph here. And what we said was, if it's OR, in most cases, it should look like ORs on the boat. You're going to have a gap in the middle, and you're going to have an arrow on the right side going off to the right. You're going to have an arrow on the left going off to the left, and then you've got this gap that's in the middle. So if we graph these two, there's negative 4. That's an open circle headed off to the left. X greater than or equal to 0, that's a solid circle headed off to the right. And there's our OR statement because, again, we've got this gap in the middle. It kind of looks like ORs on a boat when you go through this thing. Okay, and y'all remember what it was if it was an AND statement, how it should normally look? Yeah, if it's AND, it should be it's the opposite. It's everything in the middle. It's sandwiched between those two numbers, if you go about that way. All right, question 5. Back to something similar that was on question 4. Question 3. This one's going to ask you to add. So it's 4 over 3x squared plus 16x plus 21 plus 2 over 3x squared plus 13x plus 14. Okay, and the big difference from number 3 to number 5. Number 3, you had very simple denominators. Number 5, we've got complicated denominators. So it's one like this, where you have a lot of more complicated expressions here. You've got to factor everything as much as you possibly can. So we'll just say we're going to factor completely all parts. Numerators, denominators, first fraction, second fraction, everything. Factor everything as much as you can. Okay, for the first one, you are going to have to do the AC method here. So we're going to start off doing 3 times 21. Good thing is they're all positive, which makes it a little bit easier when we go through this one. So it's the factors of 63, where the sum is going to equal 16. And again, the good news is it is all positive, so that does make it a little bit easier. And the only other numbers we get, that's it. 163, 3, and 21 are 9 times 7. To add this up to 16, that's going to be the 9 and the 7. And the one thing extra you had to do on this one was because we multiply by 3 in the beginning, these numbers are too big. So to even it back out, we're going to go back and divide everything by 3. Okay. This part doesn't simplify. So that's where we're going to pull the 3 up in front of the x, do the bottoms up part here. Make it 3x plus 7. 9 divided by 3 is 3. So that one's x plus 3. Okay. Same thing on the second one. We've got to do 3 times 14, which is 42. So it's the factors of 42 where the sum is going to equal 13. And again, it's all positive, which does make it a little bit easier. See, 1 and 42, 2 and 21, 3 and 14, or 6 and 7. And to get 13, that's going to have to be the 6 and 7. Okay, and same thing with the other one. In the beginning, we multiplied by 3. So we're going to go back and divide by 3. That will simplify. Get x plus 2. This one doesn't simplify. So it's 3x plus 7. Okay, so what we're going to do is we're going to go back and rewrite both of these fractions so that they're in factored form, just so we can kind of see the layout of it here. So we've got 4 over. No, it's 2 over. Okay. Okay, so rewriting both of those two original problems in factored form, we've got 4 over 3x plus 7 and x plus 3, 2 over x plus 2 and 3x plus 7. Okay, and here's where we need the least common denominator, which again is 1 of everything that shows up here. So we need the 3x plus 7. We need an x plus 3. And we need the x plus 2. Okay, now here's where I probably would get a little bit lazy. I would go ahead and just put that this is the LCD, because I don't have to write all those things out. And then just think about, okay, if I went from here to here, what I have to multiply in to get from here to my least common denominator? X plus 2, right? So we'll do the same thing here. We're going to multiply in by x plus 2. Okay, same thing down here for this one. To get from here to here, our least common denominator, we changed it from this to this. We put in an extra x plus 3. We multiply by x plus 3 on the bottom. We need an extra x plus 3 on the top. Okay, now this, and finally we get back to where it was the same with the other one. Once you've got those two things rewritten, now you're going to bring it back as one big giant fraction. It's all over the LCD. So we're going to have the 4 times the x plus 2 plus 2 times the x plus 3. And again, that's still over the least common denominator, and we don't worry, because once we've got the least common denominator, we're not worried about the bottom part until we've done everything we could possibly do in the numerator. So that is 4x plus 8 plus 2x plus 6. It's all over the least common denominator. 4x plus 2x is 6x. 8 plus 6 is 14. Still have one more step to go, because with 6 and 14 you can divide them both by 2. So then that becomes 2 times 3x plus 7. Okay, now we've done everything you can do in the numerator. We've done distributive property, we combined like terms, get to the end, we had a little bit of a greatest common factor there. Now we can bring in that least common denominator, which was 3x plus 7. You're going to say, hey, we can cancel. Well, there we go. Get an x plus 3 and an x plus 2. Again, those 3x plus 7s do cancel. Finally get an answer of 2 over x plus 3 and x plus 2. Okay, and the good news is that should be like the longest problem that's on the test. Everything else should be a lot shorter than that one. Yeah, that's as bad as it gets. That is the worst problem that's on the test as far as length of time goes. All the other ones are just a whole lot shorter than what that one wound up being. All right, number 6. It just says to simplify. And this one's a complex fraction. Okay, we don't like fractions enough, very much. But then you put a fraction inside a fraction, we don't even like it that much more, right? So what we're going to do with this one is we're still adding and subtracting, but so we need the least common denominator. Good news is there's only one denominator here, there's only one denominator here, everything else is that part. So we're going to have the least common denominator would be 3x. Okay, and if it's a complex fraction like this one, instead of rewriting everything and combining like terms, we're going to take every single thing that's here and multiply it by that least common denominator. Now, you could go back and rewrite it, but again, if we're just trying to make it the easiest way here to kind of get through this one, is that if you multiply everything through, well, then we wind up with just one numerator and one denominator, that we don't have a fraction inside a fraction. Once we do this one, all the fractions are gone, so we have just numerators and just denominators that these fractions will cancel out. Okay, so the top part, 3x times 7 is 21x. Those two cancel out, and that's what we wanted because we want that fraction gone. You're left with a minus 5. Same thing on the bottom. 3x times 2 is 6x. Those 3x's cancel each other out and leaves you with a minus 5. And there's nothing you can do to factor with 21 and 5. They don't have any numbers in common. Same thing with 6 and 5. There's no numbers in common. So that would be your answer that's in simplest form. All right, number 7. Different question, but it's going to have basically the same setup. That now you got a fraction or rational equation, they're going to ask you to solve it. Okay, but again, on this part, you still have that you're supposed to add and subtract, so you still need to find out what the least common denominator is. Good news in this case is the only denominator is y plus 2. Okay, and with equations, it's kind of like the problem before. We could go back and rewrite everything with y plus 2's and add them together and do those parts, but if it's a complex fraction or an equation, the easier thing to do is to take both sides of the equations and multiply everything by y plus 2. So we're going to take every single term in here, multiply by that least common denominator of y plus 2. And it's going to have the same impact that we had on the first one, that now all the fractions are going to be gone, and you're going to have just whole numbers. Those y plus 2's cancel. Leaves you with the 5. Those y plus 2's cancel. Leaves you with the 2. And then just do a little distributive property at the end. 3 times y is 3y. And then 3 times 2 is 6. All fractions are gone. Now it's just a nice, easy little problem. Get the y's on one side, numbers on the other. One thing you can do, because you've already got the 2 plus 6 on the same side, go ahead and make that 8. So really it's 3y plus 8. So go ahead and do 2 plus 6 and make that 8. And then from here, I'm just going to subtract 8 from both sides. And the last step, divide by the 3. So then your y would be -1. Okay. As long as it doesn't mention anything about checking your word, extraneous solutions, just let it ride. Everything should be good there. All right, question 8, a little bit different here. Question 8 says, for each ordered pair, determine if it is a solution. Okay, so this one setup's a little bit longer here because you're going to have a problem where they're going to give you a system with 2 equations. And then the next thing they're going to do is they're going to give you a box of numbers. And they're going to ask you, okay, here's some ordered pairs. Just go back and tell me if this ordered pair is a solution or not. Okay, and they'll have a hyperlink button in here. You just go back and click whichever button you need. For now, we're just going to put yes or no. We'll put a check if it's yes or check if it's no, whichever one it's going to be. And this is nothing more than just, okay, take the numbers you have, plug it back in over here for x and y, and just make sure that it makes both equations true. Okay, so that's the yes or no answer. Does this one ordered pair make both equations come out to be true? Yes, it does, or no, it doesn't. And it's just from there, just go back and plug it back in. Okay, so this one we'll do it in blue. So plugging in that for x and y, we get 6 times 1 plus 2 times 8. Does that equal 16? That one works out kind of nice because in the very beginning we get 6 plus 16 equals 16. Yeah, that's a no. So sometimes you don't have to get to the second equation because as soon as we get the first equation, that one doesn't make sense. So obviously, there's no need even checking the second one because if the first one's not true, then there's no way the second one can be true. Okay, same thing on the next one. We'll take it one equation at a time. That is 6 times -5 plus 2 times 1. Does that equal 16? That's -30 plus 2. That does not equal 16, so that one's a no. Okay, one of these is going to have it work, both of them. One of them works here. Let's see what we got. Okay, plugging in -2 and 14, we get 6 times -2 plus 2 times 14. Does that equal 16? That's -12 plus 28. That is 16 equals 16. So far, first equation is good, but we have to check it in the second equation too to make sure it works. So on the second equation, 14 equals negative 3 times negative 2 plus 8. Does 14 equal 6 plus 8? Yes, it does. Okay, now there's a really good chance, and I'd say it doesn't work all the time because it just depends on the equations and how they set these up. But most of the time there's a good chance that once you get one yes answer, that may be the only one. It just depends on the lines and how the equations are set up. That might be that there's only one. It could possibly be that all four could be yes answers. It just depends on the equations and how they have those equations written and exactly how they're set up. I've got to check one more here. Checking the last one here. 7 for x, so that is 6 times 7, plus 2 times negative 13. Does that equal 16? It's 42 minus 26. Does that equal 16? That does equal 16. Okay, so that one checks off. So, again, got to check the second equation. First equation is good, now we got to check the second one. Y equals negative 3x plus 8. So y equals negative 3x plus 8. Negative 13 does equal negative 13, so that one also checks out. So in that case, we get two answers for that part. Okay, so just because you get one yes answer, you still got to check them all because you just never know. Sometimes it may be there's just one answer, sometimes it may be two. Again, it could possibly be, sneakiest case, they may make it so all four answers are yes. You just don't know until you go back and check every single number through this thing. Okay, the next two problems are actually how you would want to actually solve a problem like with that where you had the system. So this one tells you to solve the system by substitution. And if they give it to you where they tell you to use substitution, it's set up basically in one way because if they wanted to use a different way to do this, they'd set the problem up. So this one should be set up to one specific way. Okay, so if it's substitution, you have y equals 3x plus 11. And in one of these two equations, if you're going to do substitution, it either needs to have y equals or it needs to have x equals. And if you have one of these equations like this where you have y or x equals, basically what this means is you're going to replace y with 3x plus 11. So wherever they give you the equation, just think that you're going to take this y out and replace it with this expression that you give here. And if it comes out of this equation, we're going to plug it back in here. So 4x plus 5, and again, take the y out, replace it with 3x plus 11. And then solve it out from there. And that's the whole thing of what substitution does. It takes one of the variables out and replaces it with an expression. And that way now, instead of having two variables to worry about, you've just got one variable. And now we can actually go back and solve this thing. All right, 5 times 3 is 15. 5 times 11 is 55. 4x plus 5x is 19x. And from here, you've already got the x by itself. We've got to get rid of the 55. So we'll subtract it away to the other side. and 19x equals negative 57. Dividing those two numbers, we do get a negative 3. Okay, now one thing you can probably look for on these problems, if you don't get a integer, if you get some weird fraction or decimal, go back and check your math, because you should get a whole number when you're going through these, or an integer, because it could be negative at the same time. Okay, walking through this one, you're still looking for ordered pairs, so you do need an x and a y, so now you're going to take this answer of negative 3 and plug it in to find y. And if that's the case, use the equation that had y equals, because that's going to be the easier one to find. You can go with either equation, but the one that you use for substitution, that's going to be the easier answer, because it's just y equals this number. We're going to take out the x, put in negative 3, and then just work it out. Okay, so as an ordered pair, that would be our final answer. All right, number 10. Same type problem, but on number 10, they tell you not to do substitution. They just tell you just to solve it. So we got 2x plus 4y equals 8, and then 3x plus 4y equals 16. Okay, they don't tell you which way to go, so this one you can pick whichever option you want to go with. But if all the variables are lined up, it's probably going to be easier to do the addition method, or the elimination method, whichever way we were calling it. That basically you want to try to make it so that these two variables, or the same variable has the same number, but you need one of them to be a positive, you want the other one to be a negative, so that when you add them together, it goes to 0. So for this one, what we're going to do is, we're just going to multiply this entire equation on the bottom by negative 1. And in the top part, we're going to leave it just like it is. Okay, and then from there, just whatever it says to add or subtract, do it. 2 minus 3 is negative 1. That goes to 0, y, which is what we want, because if that's 0, it's just gone. 8 minus 16 is negative 8. Okay, and then just divide both sides by negative 1. So I'm going to get x is equal to 8. Okay, and same thing on the last problem. Once you get one variable, you still need both variables. So then you're going to take this x equals 8 and plug it in to find y. Okay, now back here, none of these have y equals, so whichever equation you pick, it's really not going to make a difference. It's going to be about the same amount of work. Because there's not one equation that's set up where it's x or y equals, just pick one and plug it in and see what you're going to go. Maybe the top one. Okay, we're going to plug in x for 8. So 16 plus 4y equals 8. Get rid of the 16. 4y equals negative 8. Dividing those two, we get y equals negative 2. Okay, so ordered pair answer would be the 8, -2. All right, number 11. Changes gears. This one, you've got two functions, and it says you're going to find f of -2 and g of 6, and then they're going to give you what those two functions are. F of x is -2 x to the third minus 3, and g of x is -2x plus 4. Okay. And again, two separate answers. You get one answer when you plug in the f of -2. You get a different answer when you. So it's basically a two-part question. So for this one, everywhere you have an x, you're going to take out the x and replace it with -2. So for this problem, same thing. We're going to do -2, but where you have an x, take the x out and replace it with -2. And just like this one is in parentheses, same thing here. When you take the x out, put that -2 in parentheses. And everything that's around the x has to be on the outside of the parentheses. So the -2 is on the outside, the third power is on the outside, and from there, just work it out. It's just order of operations from there. It's -2. If you do -2 to the third power, it's -8. So -2 times -8 is a positive 16. 16 minus 3 is 13. Okay, so your f of -2 would just be 13. Okay, again, they should have a box for one answer when you're doing f of -2. They'll have another box, here at the bottom when they'll have a g of 6. And you're just going to go back and fill in the box and tell me what that number is. For g of 6, same thing. Everywhere you have an x, you're going to replace it with 6. So it's -2 times 6 plus 4. This one, there's a lot less to it, so it goes a little bit faster. -2 times 6 is -12. -12 plus 4 would be -8. So for g of 6, it should just be -8. Okay, and that's the only function question I think that pops up here. Number 12 is similar to the problem that we did earlier. We're going to solve the compound inequality. The last one we did was an OR. This one's going to be an AND. So we've got 3u plus 6 less than 15 and 4u plus 5 is less than 29. Okay. The OR statements are usually a little bit easier because the OR statement, you graph it, and whatever shows up, that's your answer. The AND statement is a little bit more to it than that because the AND has to be the overlap of the two graphs. So this is one you almost have to have, depending on the problem, you almost have to have like a graph where you show your work, and then you take that graph and then show what the answer is. So you almost need an in-between step. But you're still going to go ahead and solve the equation. So for this one, first thing we'll do is we'll subtract 6. So 3u is less than or equal to 9. Dividing those two, so that's u less than or equal to 3. This equation, we're going to subtract 5. 4u is less than or equal to 24. Dividing both sides by 4, we'll get u is less than or equal to 6. Okay, now, if they were going opposite directions, we would have basically that they would meet in the middle, we would be good. But in this case, they're both less than, they're both pointing to the left, so we're not going to have this nice little sandwich part of it in the middle. If we graph these two, if we put this one at 3 and this one at 6. Again, this is kind of like our showing our work part here. Everything less than 3 would be a solid circle here going this way. Everything less than 6 would be a solid circle going that way. Okay. And again, if it's an and statement, you need the overlap. So you've got to tell me where the graphs basically stack up on top of each other. That's everything from 3 all the way down to infinity. So your final answer here would be, we're going to start at 3. I'll head off in that direction. All right, now the one extra thing that's on this one that we have to look at. This one asks you to write the answer in interval notation, which basically means just take the graph that you have and use the graph to then come back and give you the answer that you're looking for. Okay, and interval notation basically means tell me the leftmost number that you have, tell me the rightmost number that you have, and put those two numbers on there. This thing goes to negative infinity, stops at 3, and again with a negative infinity, that one we're going to put a parentheses around it because it keeps going. There is no end to it. So if there's not a number that you can ever get to, you put a parentheses. This one, there is a definite stopping point at 3. So for that one, you have to put a square bracket around it. Okay, in the earlier question we had, it did not ask for interval notation. It just asked you to solve it and graph it. So this one added that one extra step in here that they wanted you to have the answer in interval notation. Okay, 13 changes gears just a little bit. Then instead of having inequalities, this one's just got an equation that just says to solve for u. And you just have to remember, with absolute value, how many answers are we looking for? 2, right? Because absolute value is distance from 0, so you can either go in the positive direction or you can go in the negative direction. So for this one, if the number on the inside is 10, we're in good shape. If the number is negative 10, if you take the absolute value of negative 10, it's still going to give you 10. So for this one, we're going to solve it both ways. We're looking to see on the inside number here when it equals negative 10. We're also going to say, all right, if the inside number comes out to be positive 10, take the absolute value of it, it's still going to give us 10 for this thing. So that's going to be the two parts that we're going to solve for here. Okay, add 15 to both sides. So we get 5u equals 5. Dividing both sides by 5, we get u equals 1. This one, same steps, just a little bit different on the numbers. 5u equals 25, divide those two, and we get u equals 5. Okay. So if you can remember that when we're doing absolute value, you're really looking for two answers, not just one. That's really the biggest thing that you have to worry about, because the number on the inside of the absolute value, if it's negative or positive, once you take the absolute value of it, you make it positive. So 2 answers is what we're looking for. Okay, number 14. Same situation, but just different problem. Because this time we're going to do absolute value, but it's going to be less than 2. Okay, and for this one, we are going to solve the inequality, but it tells you to graph the solution on the number line. Okay, so for this one, I'd say that they don't even worry about the answer, really, but they don't worry about the solution. They just worry about the graph here. And here's where you have to play the word association. Less than, right? Okay. Well, so if it's less than, you have to think about that it's less than, which means it's going to be an and statement. And with the absolute values, it's always going to be sandwiched between the positive number here and then the negative number here. So whatever this number is that you get here, you're going to sandwich it between the positive and negative on that part. Yeah, just like if it's an equation, basically you had it equal to one number that was positive. You also did the same thing with the negative number. With the inequalities, you're still going to use the positive and negative of that number. It's you got to figure out which one it is. But the way I remembered it was, if it was less than, it's like than, it's an and statement. And if it's an and statement with inequalities, with absolute values, it's always going to be sandwiched between the positive of this number and the negative of this number. And then from there, you're just going to solve this inequality. If it's w minus 2, you're going to add 2. But now instead of adding it just to 2 parts, now you got a 3-part problem. And then we find out that the number is between 0 and 4. Okay, now again, they give you a big, huge number line where it goes from negative 11 all the way up to positive 11. You only really need the 2 numbers that you have here. Okay, so 0 is, or W is stuck between 0 and 4. So same thing here, you'll just graph in everything between 0 and 4. They did not have the bar underneath it. If they had the bar underneath it, these would have been solid circles. There were no bars here, so that makes the circle. So okay, and again, I'd say there's a bad thing on this one. There is a bad thing. They don't ask you about this part of it. They don't ask you to solve it. They say just graph it, and they're just assuming that if you get the solving part correct, hopefully you'll get the graphing part correct. You say, well, that's not fair. They should ask us to solve it because we did that. Well, guess what they do on number 15? So here's a problem. Solve it. Don't worry about graphing on this one. This one, you're just going to solve it. Okay, so for 15, we're solving absolute value of W minus 18 is less than negative 12. And when you're solving with the absolute values, you do have to get the absolute value by itself. So before you do anything else, you've got to get the absolute value by itself first. For this problem, that means you're going to add the 18 to both sides. Okay, once you do that, this is where you would check it. If this was a negative number, it's a trick question. As long as it's positive, now it's just a normal question. You're going to split this thing up into two parts. Now again, it's less than. So this is going to be just like the problem before. That's going to make it an and statement. So for this one, you're going to sandwich it between the positive and negative 6. Okay, and for this one, there was nothing else with the W. There was no plus 2s or minus 5s or multiplied by 3 or anything else. So for this one, once you get this part and separate it out, the W is by itself in the middle. That would be your final answer. Okay. So a few absolute value equations, then we're moving on. Okay, 16. Oops, my bad. Here's one where, when we're doing this in the homework, where you had to pay attention to the English part of it. What number is equal to square root of 100? Key thing is it says what number, right? So you only need to give me one answer. Because if they said what numbers are equal to square root of 100, that's when you got to use the plus or minus. But if it's just what number, we just need one number. Tell me what the square root of 100 is. That's 10. So then you're good to go. Now again, if it said numbers, you would need a positive 10, and then you also need a negative 10, but it didn't say what numbers, it just said number. So don't worry about it. That's it. I got it. Anybody says, thank goodness, because those other ones were kind of long. Okay. Okay, 17. Almost as easy. Square root of 100 over square root of 9. Oh, sorry, actually, hang on one second. It's one big fraction to start with. Okay, if it's one big fraction and you look at it and you go, well, hey, I can take the square root of 100 and I can take the square root of 9, well, do just that. Square root of 100 is 10, square root of 9 is 3, and there you go. All right, 18. Almost, well, I'd say almost as easy, but similar along the same lines. It's square root of negative 49. Okay, this is one where, again, if it was square root of 49, it would be 7, right? Now, here's where we got to be a little bit careful. When they ask you to evaluate these, they should tell you that, and they don't. For one like this, and again, they don't put this, but they should. They should tell you that answers should be real numbers. Because we did a section where we had imaginary numbers, which you could do here, but this one, they don't want the imaginary numbers. They just want to know, okay, if it's a real answer, tell me what it is. If it's not, tell me it's not. So if you do square root of negative 49, it's not a real number. So this one, they're going to tell you that it's not. Let's see, I'll get some more in here. So they should give you an option that this thing is not real. So they should give you an option to either put in the answer or click not real. So for this one, it's not real. Okay, next one is square root of 36. which would be 6, right? Okay, now if they put a negative in front, the only thing it does to the answer is it just, instead of the answer being 6, now it's negative 6, and then we're okay. So negative on the outside, that's fine. The answer is negative. If you put a negative on the inside and they ask you to evaluate, just tell me, okay, I can get an imaginary number, but that's not what we're looking for, so it should be that it's not a real number. And again, you should have that option here that this thing is not real when you're going through and checking this. Okay, 19. Find the value of the third root of 8. And if you took the 8 to break it down, it would be 4 times 2. 4 would be 2 times 2. So that would be the third root of, if you think about the 8 here in this case, with all your prime numbers, it's 2 times 2 times 2 to be the same thing as 2 to the third. And if they ask you to find the value, as long as this this index and this power, as long as they match up, they just cancel each other out, and everything is gone. The answer is just going to be the number you get on the inside, which would just be 2. Okay, number 20 says to simplify 625 w to the 20. Okay, and when you have variables and whole numbers, you can basically split that up into 2 parts. So we got the fourth root of 625, we've got the fourth root of w to the 20. And from there, just do the 2 parts, and at the end, come back and put your 2 answers together. If you check 625 and start breaking this thing down, it would be 5 times 125. 125 would be 5 times 25. 25 would be 5 times 5. So that's really the same thing as the fourth root of 5 to the 4th power. And this is where it's similar to the last problem. Your fourth root and your 4th power cancel each other out to just get 5. And back here, with the fourth root of w20, variable is actually a little bit easier, because with the variables, all we're going to do is we're going to take this 4 on the outside and divide it on the power on the inside. 4 going to 25 times with no leftovers, and we said this is the exponent that goes on the outside. And whatever you have left over, this is going to be what remains on the inside. So there's nothing on the inside. We're going to have w to the 5th on the outside. So it's going to be 5 and then w to the 5th. All right, number 21. Another simplify. This one is the square root of 50. All right, 50 is not a perfect square root number, so you got to start breaking it down. Depending on how you go with it. If I start breaking it down, I'm going to go with 25 times 2. And hopefully that's when you go, wait a minute. Square root 25 is a perfect number. So if I square root 25, that's just 5. The 2 then doesn't have anything else to go with it, so then my answer is just 5 square root of 2. If you happen to have not gone with 25 times 2, if you're doing 5 times 10, 10 would have been 2 times 5. Well, it's 2 times 5 times 5. Oh, there's your pair of 5s. So here's your exit buddies, your 5s get out, the 2 stays on the inside. So 5 squared 2. So which way you go doesn't matter. Hopefully, whichever set of numbers you go with there, you can see that you'll get the same answer either way. Okay. And 22, the only difference between 21 and 22 is when you simplify on 22, they give you a variable. But we'll do that just like we did in the earlier problem. Do it in 2 parts. We're going to do the square root of 54 for one part, and then the square root of x to the 10th to the other part. With 54, start breaking it down. 2 times 27, which is 3 times 9, which is 3 times 3. Pair of 3s. So the exit buddy, the 3 gets out. We're stuck with a 2 times 3 on the inside because they don't have any buddies. So go ahead and do 2 times 3 and make that 6. And with the square root of x to the 10th, remember that square root means that's an index of 2. If you divide 10 by 2, they go 5 times with no leftovers. So we do need an x to the 5th that goes on the outside. So if we put this all together, we get 3. X to the 5th, and then the square root of x. Yeah, so again, top number, whatever we divide out, that's how many goes on the outside. Whatever's left over here, that's going to be what's on the inside, which we didn't have any, so the x to the 5th just goes to the outside. Okay, 23, same type of question, just different numbers, still a simplify. This one is the square root of 8 and then y to the 21. Okay, same thing as the one before. Break it up into 2 parts. When you do the square root of 8, again, if you start to break it down, there's only one way to break it down, really. It's 4 times 2. Hopefully the square root of 4 will jump out at you. So that makes that a 2. Square root of 2 is left on the inside. Okay, with y to the 21, index is 2, so we're going to divide 2 into 21. That'll go 10 times. Negative 10. It goes 10 times with 1 left over. So for this one, we are going to take 10 y's out, but you're still going to have 1 that's going to be left on the inside. So we got the 2 that's on the outside from here. For this one, we're going to have y to the 10th that's going to make it out. On the inside, we have this 2, and we're still going to have 1 more y that's going to be left over. And that would be our final answer. Okay, 24 says to rationalize. And as long as it's just a one-term denominator, there's only one thing that you have to do. You're going to take the original problem that you have, and you're going to multiply by whatever that denominator is. On the top, you get square root of 14, and that does not simplify because it's just 2 times 7, and again, both of those numbers are prime, so there's nothing you can do with that one. On the bottom, it does make the square root of 49, but when you square it to 49, you just get 7. So then it's just square root of 14 over 7. And it's 50-50 on the top part for the numerator. Sometimes it simplifies, sometimes it doesn't. It just really depends on the numbers and how they give them to you. The main thing is when you rationalize it is that the bottom number does not have a radical. It's just a regular number. It makes it a lot easier if you have to start adding and subtracting fractions. All right, 25. Still working with the radicals. This one says to simplify. Okay, and the simplifying part basically means we're adding and subtracting. Okay, if whatever's on the inside, which is your radicands, if they're the same, you can add or subtract numbers on the outside. If they're different on the inside, which these are, that means you got to take whatever's on the inside, which is the radicands, and break them down until they are the same. So from this one, you just got to start breaking it down. If you go with the first one here, 32w, if you take the, and again, square root of 32. Now, there's only one w, so really not that one, I mean, you don't have to put the w in there because it's just one. There's nothing that's going to break out. With 32, it's 16 times 2 times w. There's your perfect square root of 16, so you can make that 4 square root of 2w. Now, this 6w that was in the beginning is still there, so it's 6w times 4 times the square root of 2w. So on the outside, go ahead and multiply this all together and make it 24w square root of 2w. Okay, second radical, same type thing. We've got the square root of 18. Now that one you can simplify both of these, so we'll go ahead and break it up. 18 would be 9 times 2. But again, there's your perfect square root, so we can make that 3 square root of 2. And w to the third, since it's so small, we have w. There's a pair of w's, so that w gets out. That square root of w is going to stay on the inside. Okay, so putting this one together, we've got 3 times w on the outside. On the inside, you've got 2 times w, so that would be 2w. All right, once you're there, now you do have the same thing on the inside. And once you have the same thing on the inside, you can add or subtract the numbers that's in front. So now we're going to do 24w plus 3w. Well, that's just 27w. And whatever the square root is, that part doesn't change. So just say square root of 2w. That basically, the square root in that case, once you break it down, it's basically like a variable. If those two things were different, if this was a 2w and this was a 3w, you can't add those together. They just have to say it's two separate radicals. All right, 28. This one is rationalized again, but they changed it up just a little bit. This time it's a two-term denominator. And with a two-term denominator, it does get a little bit more complicated. That we're going to take the original problem that you had. You're still going to multiply by the denominator, but you do have to make one small change. Whatever the sign is here in the middle. Question? Oh, it's 26, isn't it? Trying to get ahead of myself. Yeah, sorry about that. It is right. 26, 25? Yeah, there we go. Okay, sorry, I can't count. It's bad when you got a math teacher. Can't count. Okay, so for this one, big thing is, whatever this sign is, you've got to change it over here. So if that's a minus, got to make it a plus. Okay, on the top part, we said on that one, just in case, well, actually, we're going to do the bottom part first, because on the top part, we'll come back to it, because there's really not much to it. You're just going to do distributive property. You may or may not need to, but we'll kind of see. On the bottom part, the whole part of this one was, we're going to do the full method. But if we multiply by the conjugate, where we change the sign, we really don't even do the full method. Let's do the fluff method. You're going to do the first times the first, and the last times the last, because the O and the I in the middle cancel each other out. So for this one, we're going to do 7 times 7 to make it 49. You're going to do 3 square root of 2 times 3 square root of 2, which is 9 square root of 4. Sometimes that was a little sneaky. It'll jump out at you if you're not careful. So a lot of times people go, oh, it's 3 times 3 is 9, they'll leave it square root of 2. But remember, you do have to do the outside times the outside and the inside times the inside. That leaves you with 49 minus 9 times 2. So it's 49 minus 18, that is 31. Okay, now, here's why we waited on the top. If this number had simplified with this number, we would have come back here and canceled these two things out and simplified it. But because the 4 and the 31 don't simplify, this is one where they're probably going to have you go back and just go ahead and do distributive property with this thing. So we would do 4 times 7 for 28. 4 times 3 square root of 2 to be 12 square root of 2. But now, I don't think every one we've done so far, which, again, doesn't mean anything, because sometimes they may sneak one in here, but every one that we've done so far this semester, this number never canceled with this number. So you're probably safe to go ahead and do distributive property, but just in case, you might want to go ahead and do the bottom first, and just make sure that this number doesn't simplify with that number. If it does, then you have to go back and divide those two. This one didn't. I think every one we've done so far hasn't. So you would think that pattern would hold, but you never know. Sometimes they'll sneak one in on you when you least expect it. Okay, that was 26. Okay, usually 27 comes after that. So let's do 27 here. Okay, we'll go square root of u plus 9 equals 6. Okay, and for this one, it's kind of the, no, I was going to say backwards of what we were solving earlier, but we haven't done one quite like this solving yet. We'll actually get back to that one here in a minute. If you have a square root, to get rid of a square root, we're going to square one side, and if you square the left side to get rid of the square root, you do have to square root the right side so that you balance this thing out. Okay, so when you square the square root, everything cancels. That's going to leave you with u plus 9. 6 squared is 36. Now you've got just a regular equation. Subtract 9 from both sides, and u is 27. Okay, 28, which is where I was thinking we were, but let's get there a little bit too quick. For 28, it's solving v squared equals 49. Okay, here's where we got to go back to, they never called it this, but basically we had to know make this one. if you start off an equation, whatever the highest power is you start with, that tells you how many answers you need. This one's v squared, so you've got to give me 2 answers. And to undo v squared, it's the opposite of this problem back here. If you had a square root, we squared it. Well, if you have a squared problem, then you square root it. Okay, so if you square root the 49, we know that's going to be 7. But again, we know we're looking for 2 answers because it was v squared. So for this one, that's where we have to go back and tell me that one answer is 7. The other answer would be -7. Because if you squared -7, that would still be 49. So you could give me 2 numbers that you could actually get there. Okay, 29, same question. Same setup, everything looks exactly the same, so we're still going to do the exact same thing. We've got, in this case, x squared equals 27. To get the x squared by itself, we're going to square root both sides. The only difference is it's not a perfect square number, so you got to break it down. When we square root 27, that is 9 times 3. There's your perfect square root, so we can take that and make that a 3. 3 is left on the inside. Okay, and again, because it started off x squared, you've got to have 2 answers. So one answer is positive square root of 3. The other answer is going to be negative square root of 3. Okay, so again, exact same setup. It's just one you need a positive answer and one you need a negative answer. Okay, 30. Tells you to solve the quadratic by completing the square. Okay, and this is the one that had 6 or 7 steps you had to go through. They're not long. It's not as long as that one way back in the beginning because this one doesn't go faster. But it's just you have to get through the steps here to get through it. If you're going to do completing the square, the first thing you have to do is you have to get the x's on one side and get the number on the other. So move the 6 off of the left side, move it to the right side. Okay, once you've done that, then you're going to take whatever this number is with x that's here. You're going to take that number and divide it by 2. Once you get this number, you're going to turn right back around and you're going to square it. Okay, and then you're going to add this number to both sides. Okay, what that's going to do is 2 things. On the left-hand side, you're going to have something that you can factor. Again, what it kind of does is that whatever the factors are for that would get you 4, it's going to be this number back here when you took the b term and divided it by 2. So this would basically be x minus 2 and x minus 2, which means that would be x minus 2 squared. The right-hand side, just add the 6 and 4 and make it 10. And this is where they're going to split this thing into 2 parts on the online homework when we're going through these. this is going to be that first answer where they give you a choice of two boxes where one's going to be, it's in the middle. Where one of them they're going to have x plus, the other one they're going to have an x minus. So for that problem, we picked the one that had the minus in it. Put in the 2, put in the 10. Oh, sorry, it's equal something there. So you plug in the 2, plug in the 10, and then just make sure you pick the problem that's got the minus. Okay, to get the second, which is the real final answer that we need, because now that you've got x squared, we're going to go back and square root both sides. And when you square root the squared number, those two things cancel out. It's going to leave you with just the x minus 2 equals 10. But again, you're going to have two answers because you're going to have a positive 10 and you're going to have a negative 10. So then basically you split that into two parts. One answer, you solve it where it equals negative 10. The other answer, you solve it where it equals positive 10. Oh, that's square root. My bad. Hold on. Okay, so then add the 2 to both sides. So that x would equal 2 minus the square root of 10. This problem, you would do the same thing when you add 2. But for this answer, you're going to get 2 plus the square root of 10. Oh, I didn't want to try it again. Okay, so they go from solving by square roots to using the completing the square. The last handful of problems with 31, they tell you to use the quadratic formula. Which is negative b plus or minus square root of b squared minus 4ac, all that's over 2a. And the problem they gave for number 31 was 6x squared plus 7x minus 2. There's your a value, there's your b value, and there's your c value. Okay, and again, the one small little thing I would say to do when you do these, when you plug in the a and the b and the c value, I'd say put those numbers in parentheses. That way when you go back and plug them into the calculator and work through the numbers, it just makes sure that all the signs go where everything should go. It just makes it a little bit neater when you clean it up here. So it's the negative of 7 plus or minus 7 squared minus 4 times a times c. That's all over 2 times 6. Okay, and almost all the work is inside the square root right here. That becomes 49. 4 times 6 is 24, times 2 is 48, so that is 49 plus 48. So that's 97. And if you start trying to check 97, it's odd. 3 doesn't go, 5 doesn't go, 7 doesn't go, 9 doesn't go, 11 doesn't go. You start checking, none of the numbers go into it, so 97 is, it won't break down. That's as far as this answer goes. And again, you do not have that plus minus button as an option, which would be nice if it was. So one answer is going to be negative 7 plus the square root of 97 over 12. The other answer is going to be negative 7 minus the square root of 97 over 12. Okay, in 32, it says find all the complex solutions. It's the exact same problem. Still going to use the quadratic formula for this one. The only thing that they're telling you for this one is that by finding the complex solutions, that means that when you do the square root of this number at the end, it's going to be negative, which means we're going to have to use the I variable. It still works the exact same way. We're still going to take the numbers, we're still going to plug it into the quadratic formula, so that part's not going to be any different. This one, our A value is 4. B value is 5, and our C value is 2. Again, it's a little thing, but go back and take those numbers and put parentheses around them when you plug them back in. Okay. So we get negative 5 plus or minus the square root of 5 squared minus 4 times 4 times 2. It's negative 5 over 8 plus or minus 25 minus 32. Okay, 25 minus 32 is negative square root of 7. So that's the complex part because we got a negative square root. And anytime you get a negative square root, all we're going to do is we're going to take out this negative that's here and put an I variable in there. In this case, they want the I to go at the end. So again, the negative makes it complex, and all we do is we take the negative out to put an I in its place. Now, technically, we're doing negative 1 times 7. You would take the I out, replace it with I squared, and multiply it times 7. But if you squared it, I squared, it's there. The easy thing is, whenever you get a negative number, just take and put an I on the outside of the square root. You know, that's the quick, short, fast, easy way to get there. Okay. From there, now 7 doesn't break down, so that's pretty much your answer. It's negative 5. Now, one thing I did notice, and I don't know why they did this. Instead of putting this over 8, like we did on the earlier problem, this one they break it up and put both over 8. I don't know why. Look, I would, if this was a 4, I would see that, because that would simplify. Nothing simplifies, though, so I don't know why they have to break it up there. But we're going to stick with the format that they have, and that's what they have. And they have the I actually on the outside of it over here. I guess they separate it that way just to make sure that you know that the I is not inside the square root. That's out separate from it. All right, and the last one. Radiograph the parabola. Okay, and all you're going to do, again, it's going to be kind of hard to show it here when we graph this one. We'll do the best we can with it. Is basically you're just going to make, now one thing we do know, it's going to be a curve, something like this. But what you have to find is you've got to kind of find a couple of specific points along the way when you go through this one. And from what I can tell with the way the answer is set up here, that basically what we're going to do is You're almost going to make like a little chart. Now, you can pick the positives and negatives if you want to, but here's what we're going to do. If it's 2x squared or 3x squared or 5x squared, whatever number, as long as there's nothing added or subtracted back here, then this thing will always start at 0, 0. So if you take 0 and plug it in, you get 2 times 0, so you get 0 for that part. Okay, then just plug in 1. That's 2 times 1 squared. 1 squared is 1, so that's 2 times 1, so that would be 2. So that ordered pair would be at 1, 2. Okay, and then plug in 2. That would be 2 times 2 squared. 2 squared is 4. 2 times 4 is 8. So this point would be at 2. 8 way up here. Okay, and the only thing you have to do for the other side is that basically these are going to be mirror images. So if this is one space over to the right, you're going to have another point that's over here that's one space to the left. And if this one is 2 spaces to the right, same thing, if you go over 2 spaces here, you have another point that's going to be a mirror image of it over here. And then just go back and connect the dots. Nice smooth curve, so you get a graph that should look something kind of like that. Maybe a little less steep, a little more steep, just depends on what number they give to you here.